Hello! Today we are talking about rationalizing the denominator. What does that mean? Basically, we want to get the radical out of the denominator. If we see a radical in a denominator, we don't want it there. So rationalizing the denominator is the process of moving that radical basically from the denominator to the numerator. So there are basically two steps you want to remember here. Put these in your notes. Multiply by a fraction equal to 1 so that you're not changing the original fraction you have. And to figure out what fraction that should be, you want to use the radical in the denominator to determine your fraction. So make sure you have those steps written down in your notes, and we're going to look at a couple examples. The first example we have here is 5 over radical 3. So we don't want that radical 3 in the denominator. So what we're doing here, I've just moved the problem over, 5 over radical 3, we're going to multiply it by radical 3 over radical 3. So I'm multiplying by a fraction equal to 1, so I'm not changing the value of this fraction, and I've used the radical in the denominator to determine what that fraction should be, because radical 3 times radical 3 is simply equal to 3. 5 times radical 3 is 5 radical 3. So our simplified answer is 5 radical 3 over 3, and we have removed the radical from the denominator. If we look at our second example here, we have 4 over radical 2. Okay, we're going to multiply it by radical 2 over radical 2, using the denominator to help us figure out what our fraction equal to 1 should be. And then we get 4 radical 2 over 2. Is that our final answer, Ms. Pariseau?
Well, I don't think so, because I think something more can be simplified.
Indeed, 4 divided by 2 is 2. So we simplify it further to 2 radical 2.
Oh, that seems easy.
A lot of 2's. So, remember, when we're rationalizing the denominator, our goal is to get the radical out of the denominator. So you'll see I've written 3 examples down here. We're going to do one at a time. So write down the first one, pause the video, and try to solve it on your own. Welcome back. I hope you paused and worked on the first example. What is our denominator here? Radical 3. So that's what I'm going to use to create my fraction equal to 1. 18 times radical 3 is 18 radical 3. And radical 3 times radical 3 is simply 3.
Ooh, can I simplify that more?
You can! 18 divided by 3 is?
6.
Correct. So your final answer should be 6 radical 3.
I got that right when I paused the video.
Good job. I hope you did too, viewers. Okay, write down the second example, pause the video, and try to solve it. Welcome back. All right, this one looks a little bit harder because there's a radical in the numerator, but we have to use what we remember about simplifying radicals and apply it here. First of all, the radical we see in our denominator is radical 2. So we've got radical 2 over radical 2 is our fraction equivalent to 1 that we're going to multiply this whole thing by. 3 times radical 3 times radical 2. If you remember from simplifying radicals, radical 3 times radical 2 is equivalent to whole radical sign over 3 times 2, which equals radical 6. So we have 3 radical 6 over 2, this 2 right here, it's the same 2, times radical 2 times radical 2, which is also 2. So that leaves us with 3 radical 6 over 4. And that was a trickier one. Hopefully you got it right, or if you didn't, you're going back and correcting your notes right now. Pause the video after you write down the third example and try to solve that on your own in its simplest form. Welcome back. Hopefully you paused the video and solved our third example here. We're going to use radical 10 in the denominator to determine our fraction. So we have radical 10 over radical 10, which equals 5 times radical 10 over 8 times 10, which equals 80, which simplifies to
1 over 16.
Indeed, and we still have our radical 10 there in the numerator. So our most simplified answer is radical 10 over 16. We hope you've enjoyed this video on rationalizing the denominator. See you later.
Bye.